Good morning, everyone. This is the series of seminars Vespa put together for you. This one is the series of e-commerce AI quick fixes. And today is the one with the first one of the whole series of 4. And it's called the zero result problem. And that in context of using AI to fix some of the problems here. I'm going to wait a few minutes to get everybody up and running. And then in the meantime, just some information for you. There are some resources available for you if you go to the resource tab on the bottom of the screen here, as well as please feel free to ask questions in the Q&A section. During the session, if you like, we're going to collect those questions and then answer them in the Q&A session at the end of the presentations, so that we can answer most of the questions you have. I hope you have lots of them, and we're looking forward to them. Quick introduction to ourselves. My name is Jürgen Obermann. I'm the Senior GTM Executive for EMEA APJ at Vespa. Together with my colleague, Piotr Kopczakowski, who is a Senior Principal Solution Architect, we will show you today how we can solve the zero result problem. Both of us spent many years, more than 10 years in the big data and analytics space, 7 years of those at Elastic and the last 2 years at Vespa. With that, next slide, please. Quick overview of what we are doing. We're talking about solving the zero result problem. We talk a little bit about Vespa's advantage here. Piotr has a very exciting demo how to use AI to get this problem solved and make your customers happy. And at the end, we drive the conclusion, have question and answers for you. With that, let's start with the next slide and talk about the zero result problem. So what is that really? I mean, you can imagine that when you tap a search in an e-commerce website that you get no results back. That would be the worst case scenario, and it would be even worse if the result is zero and despite you have information or products in the stock with that. So that's the first problem. The second problem is really a zero relevance problem where you get results back which are overwhelming. Let's say you search for ski trousers and then you get 1,000 objects shown, and there's no way you can actually find the information you want or the product you want. So from a user perspective, that is really an experience which is disappointing, and it leads mostly to people leaving the site and worst case even go to a competitor's site. Obviously, you will miss the seller's objective to sell their products and goods. And the interesting thing is that there's a nuance also of different objectives. Of course, the customers come and they want to have a good experience, but the sellers, they also want to drive certain objectives like emptying stock or do promotions with their partners or any of these kinds of things. And to match those in today's world is very difficult. And today we're going to show you how you can actually address one of those. Now, if you look at this from a seller's perspective, next slide, please. You see that the sort of the way customers come to e-commerce websites today has changed a bit. They are not just coming, typing in some text to find something and expect lots of things to pop up. They come with a very specific idea of what they're looking for: specific shapes, colors, styles, brands, sizes, whatever that is. They want to be able to filter by technical specs, price, and make it relevant to them. And they're really expecting a more personalized view of their products they're looking for. So they don't just want to get a whole lot of pages and pages of items. They want to feel like it is really relevant to what they were looking for. On the other hand, if you look at the buyer side, next slide, please. Obviously, buyers have also their objectives with what to try to present to their customers and what they like to push. They have things in mind like balancing out the stock. if there's new products coming in, they might want to push the old ones at a better price before showing the new ones. They want to look at promotions. If you have things like, special days like in the Netherlands, the King's Day, where everybody runs around in orange clothes, they want to make sure that is keeping the context of the customer's requirements, still show everything in orange. It seems that also if you have like platforms where you have multiple vendors and you want to promote a certain vendor, you be able to do that, still keeping the customer's preferences in mind. Also, you can look at things like for like particular business reasons. You have other inventory you want to push or things like that. You can also use look at different drivers. Like we have the Winter Olympics going on right now, and you want to push particular items which are related to Olympics because people tend to want to buy things when events like that happen. Or alternatively, if somebody looks for rain jackets in the north of Norway or in the south of Italy, there are different requirements how a rain jacket should look like. So these kind of seasonal and cultural moments should also be able to be represented. Now, with that stated, you can see there is quite a problem to be solved. And obviously AI is helping to solve one of those, or lots of those, in fact. And with that, I give it to Piotr, who is going to explain a little bit more what the technical aspects of that situation is and how Vespa can help to solve that. Over to you, Piotr.
Thank you, Jürgen. So before we go into the technical aspects, how Vespa is providing you the features and then how you can solve these problems, let's think about the overall approach and then how we do that today. So I think that there are a number of different issues or problems which needs to be solved to provide to the users, to the buyers, proper system so it would make it comfortable to be used. So first of all, when we look at that, shoppers don't speak the catalog language. So what does it mean? That typically users will put some keyword, but then there is still intent missing. So without additional processing of that intent, it will be very difficult to understand what user is looking for. So that leads us to define particular rules based on our experience, how this tokens or let's say keywords are used. So for example, if we look for bags or we look for other items, we need to know which bags are the mostly popular in our shop to be searched for, and then we can apply the rules to exclude those which are not relevant to the most of the buyers, right? So then it leads us to maintain many rules, which is becoming really hard over time because we need to basically track what happens in our system daily. So basically this requires probably some automation and other approach with machine learned models, and then use it for extracting this data, not manual rules which will be used. So then again, if we approach with the hard filters, means that we will let user filter by colors, shapes, sizes, and so on. There will be at some point missing some other items in our system, in our shop, because this will be really limiting very fast what kind of items they can see. This is also not desired outcome either for seller or buyer, because then both will miss opportunity to buy or sell. So in current systems, it's very difficult to put everything in dynamic motion. So retrieval and ranking and user interactions are always basically separate. So quite often ranking is calculated offline, then imported to the catalogs, and this will be presented. So those will be batch data, which is delaying the reactions and then behaviors, and also it's degrading the experience for the users. So now, how we look at Vespa and then what Vespa provides to you. We accommodate all these necessary features into one single platform. So Vespa is the platform which starts from search. Obviously, search is a big topic, so information retrieval is the core of this system. But it cannot really live today without the other two components. Ranking, where you can control your business logic, where you can control how information retrieval works, and also recommendations and recommender system or personalization system, which works in tandem with all of these components. But there's three different items or solutions cannot live today without machine learning, and machine learning requires two fundamental things. It requires machine learning model inference, where you can put some data, and then this data will be processed, and then based on that data we'll get outcome which will direct the system behaviors towards the desired outcome. And then these models will be exposing the results into so-called tensors. Tensor is the way how you can represent any type of mathematical data, and tensor operations or processing enable to run operations on the mathematical operations on full series of data. So imagine that we have vector. Vector is a series of numbers, and you can do one single operation to calculate values across all dimensions at once in the core engine of tensor operations. So talking about this, then we believe that tensors are really fundamentally different approach, which enables us to not only work with different types of models. Vespa enables you to use models in ONNX format, so mostly everything which you will get from open source world or even commercial. So formatted into ONNX, you can use directly in Vespa. So tensors in Vespa are basically represented in a very nice uniform way, that it doesn't matter if you operate on single numbers, vectors, map of vectors, matrices, then you can use always the same expressions, the same fundamental, let's say, atomic operations on tensors, and then use them for creating functions or functionalities, which will be really beneficial in e-commerce platform. So what does it mean actually, model inference in search? So why this is so important? So when you think about machine learning and how this is used currently in the system. So first of all, we have a semantic search. So semantic search enable us to embed the text into transform it into the tensors, vectors. So those are typically the vectors which will be representing our, let's say, text, and then how the text relation is looking. So then we have the same for our questions or the queries, which will be embedded the same. And then that's the first understanding for everyone how the vectors are used in the systems. But then in Vespa, you can use model inferencing in other areas. So you can use these models for personalization in our ranking system. You can use them you can use them basically to benefit from collected data like user clicks, some metric data like conversion, profit calculations, and many other things to derive ranking for each item separately. And obviously, when you have this kind of pipeline, this will vastly outperform the stateless approach, and also the hard-coded relevance approach calculated offline in the systems and then fed to your catalog, because this will be done per user dynamically in real time. So let's summarize this advantages, and then once again repeat the benefits of using this kind of solutions in your e-commerce. So you can dynamically look into the inventory. The levels of inventory can be one of the expressions in our ranking system. So whenever your let's say inventory levels are changing, it will influence automatically, directly when it happens, your ranking profile. So for example, if you see that your items are almost gone, and then you have some other items which are much higher in your stock, then you can automatically reshuffle ranking, so the items will be balanced across your shop. So if you like to, let's say, make your sales based on the weather forecast. So let's imagine that tomorrow forecast shows that there will be heavy rain, and for the next week, and people are in the seasonal, let's say, holidays, and then typically they are preparing for the holidays. So what they will be buying. So if there will be 2 weeks of rain, then they will probably be looking for the raincoats and other things, maybe umbrellas even. So what if you can actually take this data and then in your category pages, everything which they will see when they enter your shop will actually be rain ready items. And then this is really easy again, because you can get this data from the weather forecast systems. You can feed that into Vespa as just single signal, which will again influence the ranking process for items which you have in your shop based on that weather conditions, which would be, let's say, coming days. Jürgen already mentioned about cultural events. So cultural events can be encoded as tensors. Tensors will can influence, for example, similarity for different events, similarity across your items, and then you can present those again in your category pages for given days or times, or even geolocations. So geolocations can be fed as an argument as well to the queries, and then you can get the results into that as well. So what actually gives us the huge benefit when using systems like Vespa, so real-time processing platform, is that you don't have any more batch jobs and overnight processing of your ranking profiles, ranking for your business logic. Everything goes in live and dynamically changed over time. So I will show you a little demo how this kind of behaviors can be implemented to process the real-time personalization jobs. So sellers and product operators will be able to see real-time results of their changes. So imagine that you change your business objectives, because immediately when you introduce maybe new product, and then you see that something is happening on the market, maybe your competition changed something they are offering, and you are losing your let's say sales, which is very important for you, because maybe a new product will be released tomorrow and you're still stuck with some elements in your shop. You can quickly modify that without waiting for overnight reprocessing, and you can see the impact directly when it happens. And obviously Vespa enables you to do really nice A/B testing. So that means that every configuration in Vespa can be treated separately, and you can direct traffic from multiple different tagged sources. So then you can do A/B testing on group A and B, and then calculate the metrics which will tell you how this was performing, and not on the long runs, but then you can do also on the short testing when you for example, introduce the changes in the peak time to see how this will be performing. So what you'll get with Vespa when you introduce Vespa. So definitely the performance will be one of the big aspects on the beginning before we talk about business objectives. But then in general, when you have personalization, when you have much faster discovery, better query treatment, then you'll have much less bad results. So that will introduce much greater satisfaction. Jürgen mentioned about looking for trousers. So I think one of the biggest problems is that now these days shops are having extremely big catalogs. Whenever you look, it will be like into thousands of different items. So without personalization, without ability to describe what you're looking for, you'll get too many results, and too many results means too much time actually going through them and checking, let's say 20 or maybe even 100 pages of results. What is exactly your thing? But then imagine that you have your pattern, your colors, everything you like, and every time you come back to your shop, you see new things, but in your taste. So that's extremely big improvement over what you see today. So market-driven campaigns enabling sellers to quickly react to to new, let's say, market conditions, agility in that space. That's really something which enables businesses to grow much faster. So it will be possible to optimize your inventory, produce dynamic promotions, or many other things. And then this is all thanks to the Vespa components like ranking and then model inferencing and possibilities which comes together with AI. So now let me switch quickly to a little demo. So I'll explain how this can be implemented in real life. So what I need to mention here, that everything what you see here, so it's like description. So the descriptions here is generated by AI. So how this demo was created, and really we have got customers also who use similar techniques to use them in their system, is that this is generated with the AI. Also, we came across the idea that models today, the VLMs, are able to represent data in almost same way as humans. So as you see here, this is key value pairs. So you have the keyword, which represents some parameter of the image or fashion item, and then weight. Both of them are generated with the VLM model. I got many questions already about the how weights are generated. So all weights and all keywords basically are generated by the LLM, but keywords are from the list provided to the VLM. So VLM is not inventing new names. We are using the keywords which are basically prepared for each fashion item category. So now when you see that, it describes pretty nicely the parameters of that with the weights, how important that feature is to that element. So now let's switch quickly to the search, and then let's maybe look at how maybe similar items can be detected with that. So you see that the shapes of the items here are very much similar from the color perspective and even shapes. So if we go maybe to some t-shirts, again, we have t-shirts which are the same shape, because as you remember, every element, every component of that item is described through our sparse representation vector. So then here is the similar story. So we have blue shirts, and then the shirts are having the same patterns and the same look. So now let's do the experimentation. Let's go and then see how this would be personalized view. We'll change to semantic search, which means that we are searching through the text and description from our items, and also we'll look for, let's say, gold shoes. So now we have gold shoes, and then you see we have how many results? 700 results, right? So are those shoes we want to see? So maybe this is not the shoes I like. Maybe only the high heels are the shoes I like to see. So look what happens when I will be using the simulated signals. These buttons, thumbs up and thumbs down, simulate my clicks on my on the website, or maybe basket adding, or maybe other signals which users are doing. So after clicking just 2 times here, we see that the system adjusted automatically to my views, and now most of the shoes are in my taste. But the more I click, the more I basically teach the model to understand what is my weight, what is my preference. And you see now high heels are in most elements, in most items here. But now this will be producing the new front page, category page, that when I enter, then I have most of things which I like to see. Obviously, there is no data diversification because I interacted only with this item. Diversification can be also created that users will see multi-categories or multi-other areas of your shop even before they start looking and searching for things. But now let's look into the system and then how this is represented in the user profile. So as you see here, I have as we got items, and each item got their own representation with features like you see here: gold, leather, glossy, and it has its own weight. How important these features are in the overall picture, the user personalization. So it's not like in dense vector representation where you have just numbers and positions in this vector. Here we have key value pairs. So the key value pairs, and many of them, this is called sparse representation because we don't have continuous space, but we have just the tokens, so basically keywords which are representing dimension, named dimension, and then value of that dimension. So you see here is black. Black is pretty low, but what happens if we change that black to maybe other value? So let's basically change it to 10. So now let's see if this is changed to 10. So yes, we have black 10. And what happens to our results? So you see, our preferences didn't change from the shape perspective, but maybe color changed. And then this enables us to control how the system will be showing the personalization elements in our system based on user interactions. But we've been talking about one thing, which was effectively filtering. That filtering is changing the way how we see items. That will limit the, let's say, recall. So that means that we'll see less, not basically similar products. So with this approach, we can change the way how we filter as well. So imagine that we'll be focused on colors, right? If we do filters in standard faceting, we can do black, blue, green, or one or the other one, or maybe select few. So that will be or operation or just single one. So in here, we can put weights against each color. So let's say we can do green, that green will be probably biggest value. So this is 5. We'll say that we like yellow. Yellow will be 3. Then we can say maybe black. This will be 1 or maybe 2. Then we'll say red is -5 because we really don't like red in our preferred clothes or items or even shoes. So, but we like really these colors for every cloth element. So now what you can see that those are the colors which are present in our clothing, in our preferred views. So I hope that this gave you some perspective of how this can be influenced. So obviously Vespa enables you not only to do this kind of things easily, but you can enable all other areas in the systems as well. We'll be covering multiple other topics on the next sessions, how you can implement other things in e-commerce search. So thank you very much. And I will leave Jürgen to do the final summary. Let me actually share back the slides. And thank you very much for your attention.
Yeah, thank you very much, Piotr. That was very interesting. And yeah, to summarize, the zero result problem is definitely a problem which needs to be solved, and it could be very damaging to your business. However, as you could see, it's definitely a solvable problem. And you know, you probably saw that there's AI everywhere. You know, the catalog generation, the feature extraction with LLM and VLM models, and obviously with the tensor operations in Vespa. So the good news is that while user expectations are growing and are getting more precise, AI will be able to help you to address that. And Vespa is an all-in-one platform with a real-time architecture, which is actually uniquely positioned to help you using these AI features to do that. And in reality, this is actually something which I mentioned in the beginning. The customers have one view and one set of interests, and the sellers have another view and interest. And those, to combine those is a challenge. And I think you saw today how Vespa can help you to do that. To give you an example, one of our customers had by just moving from one implementation to Vespa, 19% increase in conversion rate. So these are the type of information you can actually achieve. Now, having said that, if you like this, the next seminar series, as Piotr already mentioned, will be on the 11th of March, and there we talk about the relevance problem. And with that, I hope you have asked lots of questions. And if not, please do it now, because now we have time to answer questions for you. So let's start with the Q&A session. All right, first question is, how does your approach differ to other Lucene-based solutions? I think, Piotr, you're best positioned to answer that one.
Yes, so obviously there are many similarities and many differences between Vespa and Lucene-based systems. So the main, I would say, is the presence of ranking algorithms which you can use in the system. So I think this is putting the most significant, important functionality in Vespa, that you can blend business, your standard search related terms or objectives into one single system. So basically, the other topics are more deeper into the technology. So for example, how you maintain the platform, how you divide data. So instead of shards in Lucene systems, Vespa uses logical, basically logical architecture for the data. So you don't need to reindex, you don't need to scale systems in that similar way. And then also, if you think about vector searches and then actual approximate nearest neighbor and HSNW graphs, this enables you to use full node memory to create graphs which are much bigger and then would be working very efficiently. But then, of course, there will be many more, but we don't have time to describe this, so that detailed here. But then I will ask everybody who wants to know more about Vespa to just reach out to us, so we can really show you lots of different differences between Lucene and Vespa, so you'll see where you can benefit from that.
Then we have another very interesting question. What volume of offers products can you support? Piotr, that's also one for you.
Yes, so I don't think there is any limitation in that. So we have customers or users of our platform which are really vastly grew the number of products or offers above billion. So we can do billion level search of the vector searches and also logic on those, and then it will work really effectively. So there are many optimizations which we can support. Again, I'm welcome you to have a discussion with us. We can show you what kind of optimizations and how you can optimize your memory in this configuration, so it will be not something which is not doable. So yes.
All right. The next one is, can you name any matrix improvements after Vespa implementation, i.e. CTR, CVR improvements?
So Jürgen already mentioned that it's usually coming from few percent to even we recently saw 19% in the conversion rates, which is based on introducing the live personalization approach. And I think this is one of the most significant changes, personalization, which is giving you to the catalogs which are having a lot of similar products. So it's like cars, fashion, clothes, and so on. This really makes a lot of difference.
Yeah, maybe I can add to that. We have seen improvements like 19% of conversion rate, 2.5 to 5% of VIP view in average page views, and in 5 to 10% even in category views on catalog views. So I think there's we can actually talk that more directly if you have questions directly with you. But there's quite a number of improvements we can point to. All right, then there was another question. Can Vespa be used in the sponsored offers retrieval and integrate with other scoring models, in-house or ads auction modules?
Yes. So Vespa again. So how this can be, how this is done in Vespa. So outside calculated scoring models. So it depends if you actually mean that the system will pre-calculate those in your custom logic outside of Vespa, you actually import into Vespa. So obviously you can use that when it's calculated offline. It can be used in Vespa as an attribute in your catalog, and then it can be fed into ranking process, because that's native way of actually how you can use it. If you have that as your own model developed, and then you will be able to convert that model into NNX format, you can directly put that model into Vespa. I already mentioned that Vespa has these tensor operations, tensor representations, which enable you to put any type of model which will be outputting the data into the tensors, and then operate on that. And then you are asking about sponsored offers. So from our perspective, it's like more ad serving, and Vespa is excellent in ad serving. And we actually our system is used to drive one of the biggest platform in the world, which is called Taboola. Taboola is using Vespa for global ad serving worldwide, with the really low millisecond response times. And then everything obviously can be integrated into ad serving. And then you notice the profiles of the users who are interacting with the system are extremely high value for the ad serving as well. You can integrate those profiles into ad serving, so you'll create ads which are relevant to the users, not just blindly shooting the ads.
Thank you, Piotr. The next one is, give me an example why staged ranking matters in vector search.
Yeah, so stage ranking, we already mentioned that it enables you to blend the logic of the business logic and also the standard relevance logic for the traditional text search. But it's not only that. So staged ranking enables you to gradually change the effort which needs to be spent on each of the stages to get the fast responses. So imagine that you have full catalog, and let's mention the numbers you've been actually asking in the previous questions. Let's say 1 billion of the items. So when you have 1 billion of the items, you cannot spend time on making or running very heavy model or hard processing on that billion elements, because it will be simply too slow. It will eat too many resources. So what you'll do instead, you'll do query prefiltering. Then the next stage in the first stage ranking will be use lightweight model to get only the top candidates to be passed to the next stage. And next stage in our ranking can use, let's say, bigger model and or even bigger representations. So first stage may use, for example, binarized vector representation, which would be 30 times less hungry in memory. So you know how memory is expensive today. And then if you divide that by 32 times, it's already much or big saving in the cost of your platform running, either in the cloud, even on your premise. Either way, you pay a lot for memory. It will be faster to actually retrieve and search. And the next level, you can use full precision FP32 vectors, which are giving you the excellent results, but those will be stored in the disk. So you don't store, let's say, petabytes of data or vectors in memory, but you can stage it from stage one, binary memory small, and then you go into the big vectors, which enable you much higher precision on the recall. So, but there are many more use cases for stage ranking. So again, if you're interested to learn more, we can spend some time with you and then explain you this more.
Okay, the next question, Piotr, is what is the difference between what was shown here and the other vector DB solutions in the market?
So I would say that, so typically people call Vespa vector database, and then we in Vespa, we call Vespa platform. And I think this is the fundamental difference between other systems, that we are a search system, we are a vector database. We are basically the platform inference platform as well, because we can inference models. And so we can also write the custom modules very quickly, because we have a very nice chained, let's say, structure or architecture of our system, that where you can put your own document processors, your searchers, your servers, or HTTP handlers. Anything you can imagine which will be required for your project is in one single platform. You don't need many places together. And then, of course, ranking. Ranking is typically not in vector databases, as we discussed already. So you don't need to have a lexical search system. You don't need to have separate vector search. You don't need to have separate ranking or even inferencing. All of it is in one single platform. So that's why we are not vector database only. We are platform which does many things at once in one single place, close to your data. So you don't need to pass this data around. You save all latencies and also the response times.
Thank you, Piotr. So I think that's all the time we have today for questions. And I would like to remind everybody that the next webinar in this series is on the 11th of March. We're talking about the relevance problem there and how to solve that. Again, if you need any information, there's a few more minutes to take it out of the resource here, or just contact us and let us know if you need information or you need any help with anything. With that said, Piotr and I thank you very much for joining, and yeah, see you next time. Bye-bye.
Thank you, bye.